All right, today's lecture is on Dalton's law of partial pressure. Sorry if it's a little fuzzy. It's pretty simple. It's just the sum of all the gases components equals the sum of the total gas mixture. So in a mixture, first of all, we'll make some assumptions of an inert gas, so gases that don't react with each other. So we can calculate the total pressure of the mixture, and it's always the sum. Gosh, that's so blurry. Of the partial pressures of each gas. So we take the total, is add up the partial practices. So the first one isn't too bad. Total pressure of 3 gas components of a mixture is 555 torr. So I'll write it PT, which is the total pressure, and then it's going to be gas A plus gas B. Looks like we have gas C. In this case, we know the total, which is 550 torr, and then gas A is 200, and then 75, and we're trying to solve for gas C. So we just like you would expect, take 550, add those together. Using algebra, subtract 275, and you'll get 275 equals the partial pressure, of course. Now, it's important to write units, so make sure you throw in the units that we were using, in this case, torr. Okay, how about the mixture of helium, neon, and argon? Exists a total pressure of 74. I'd like you to try that one, but if you want to pause the video, go ahead and try it. I'll go ahead and give you what it is. It's just you take the total pressure, and then you have your oxygen, and you have your argon, nitrogen, and we don't know argon. Oops, I should have wrote pressure of argon. So in this case, we know the total pressure is 74, and we know that the sum of these two is 60, 20 plus 40, plus pressure of argon. And so we just subtract 60 from both sides, and we have the pressure of argon is equal to 14, and use those units of kilopascals. Now we could also talk in terms of moles. Just remember those are units of measure. So if we have a cylinder filled with 2 moles of krypton, 3 moles of argon, and 5 moles of helium, what I want you to understand is 1 mole of any gas is equal to the same volume of that gas. So I can just say it's like 2x of krypton plus 3x of argon plus 5 moles of helium. Each unit of gas equals any other volume of gas, so they exert equal pressure. So you just treat these as common units. And then what's the partial pressure of the total? So it looks like it's at standard temperature pressure. So we're going to write it's 1 atmosphere. That's what standard temperature pressure is. I add these up and I get 10x. All of these gases exert 10x atmospheres of pressure, or add up to 1 atmosphere of pressure. So each unit of gas, x units of gas, equal 0.1 atmosphere of pressure. So in this case, what is the partial pressure of argon? Argon represents 3 units. So 3 units is equal to 0.3 atmospheres of pressure, because it's 0.3% of the total. Okay, how about the next one? 4 moles of xenon, 3 moles of helium, 1 mole of krypton are combined in a closed container at standard pressure. What is the partial pressure? Try that one on your own and pause the video or follow along. We have 4 units of xenon gas plus 3 units of helium gas and 1 unit of krypton gas. And we know together they add up to 1 atmosphere because they're pressurized to 1 atmosphere. And that adds up to 8x units equals 1 atmosphere. So each unit of gas is equal to 1/8. One-eighth atmosphere is equal to 1 unit of X of gas. And we want to know the helium, and helium is 3 units of gas, so it's 3/8 of an atmosphere. All right, on the test 2 there is density, and it's just a little bit of review. Density equals mass over volume, so we can find the quantity of matter given a density. Take a look at the 2 boxes below. Each box has the same volume, so boxes are filled with the same volume, but one gas tends to be more dense than the other. The box on the left would weigh more because there's more matter inside of it. I hope that makes sense. I think it's pretty obvious. The box has more balls, so more mass per unit volume. This property is called density. The density helps distinguish from some materials. The mass is usually expressed in grams, and so grams per cubic centimeter or grams per milliliter. And you might want to know that 1 milliliter equals a cubic centimeter. And that concludes our notes today.